this tutorial, you will learn how to make a correlation matrix and calculate p-values for a correlation using Excel 2016. Let's begin by taking the variables of interest and placing them in a new sheet. So here I will highlight height, shoe size, number of shoes, happy, funny, calories, and exercise. I will copy all of these values and paste them in a new sheet. Now that I have all of my variables in a new sheet, I can use the Data Analysis Tool Pack to create a correlation matrix. If you have not previously installed this, please look for the handout on how to do this. The Data Analysis Tool Pack can be found under Data and then Data Analysis. We'll choose the option for correlation and then click OK. The input range will be all of these columns of data, and because I highlighted the full columns and they include these labels here, we will check the labels in first row box, and because my data has a column header and then goes down, I will leave it grouped by columns. For my output range, I'll put it in my same sheet and click OK. Excel has now automatically created a correlation matrix of these variables. I can view it here and see the correlation between each pair of variables. Unfortunately, Excel does not give me p-values for these correlations, so I cannot just automatically check which correlations are significant. If we do want to check which correlations are significant, we can do a further test. So if I wanted to know if the number of shoes I have is related to how happy I am, I can look at the correlation and it's fairly weak at 0.29. But to figure out if this correlation is significant, I can copy these two variables into a new sheet. So I will take my number of shoes and happy variables, I will copy them and paste them into a new sheet. Now we'll have to use the Data Analysis Tool Pack again, but we're going to use a different function called regression. This function is very sensitive to missing data, so before we proceed, we must delete any rows for which we have missing data. I'll highlight both of my columns and click Sort, and then sort by the number of shoes, and this will put any missing values at the bottom. Here we have a missing value for number of shoes, but we do have a value for happy, so we will just delete this row. We can sort again now by happy. And now the missing values for happy will be at the bottom, and we can delete those rows as well. Note when I sorted, I was sure to include both columns in my sort so that these matched variables, these matched values for each person's response stayed together. Now that I've cleaned up my data, I can proceed. I will use the Data Analysis Tool Pack again, but this time I will use the regression function. So clicking on regression, and OK. Since I'm just using this as a correlation, it doesn't matter which input I pick as Y and X, so I will just put number of shoes as my Y, and I will select happy as my X. And note here that I didn't select the entire column by just clicking on A or B as I typically do in these videos. This is because for the regression function, and only for this function, you cannot select an entire column of data. If you do, you will get an error message. And as I said before, if any missing values had been present in either of these columns, you would also get an error message. Now that I've selected my data, I did include my columns, so I'll click the labels box to tell Excel that I've included those. I will output my data in this spreadsheet, and just the standard output will give me everything I need, so I'll click OK. Because I'm only using two variables, you will see that this multiple R will be equal to the correlation we found in our correlation matrix. Our square is now calculated for us, and if we would like to know the p-value for our correlation, there are two places we can find this information. We can gain this either from the ANOVA significant test or you will see the same exact value repeated as the p-value for our coefficient happy. This p-value of 0.01 indicates that it seems that if we're using an alpha level of 0.05, then our correlation of 0.29 is a significant correlation between the number of shoes and happy. This is a long process for getting a p-value, so I wouldn't recommend doing it for all of your values, but it is a process to get a p-value fairly easily using Excel for any correlation. Remember that you can only do this one value at a time because we're trying to measure just the correlation. If we had put multiple variables in here, then this p-value would not be the p-value simply for the correlation.